with this session, and okay, if you guys want, I can allow you to record the session for your own reference, right? You can save it in your, those of you who are attending from the laptop, you can save it. Okay. So I'll be starting from very basics, because even though some of you are aware about it, but we will be learning it from the very beginning so that nothing should be missed, and whatever important points are there, whatever essential points are there, that is what you should be aware about. Okay. So let's start with it. So what are vectors? Any idea? So those of you who have heard about vectors, any idea? What are vectors? Yes. What's your name, dear? Shritik. Yes, Shritik. What are
Sir,
vectors?
vectors are the quantities which both have direction and magnitude, sir.
Okay. So I'll correct it a little bit. Vectors are physical quantities, right?
Yes,
Vectors
sir.
are physical quantities which have both,
Magnitude and direction.
okay, magnitude and direction. So Harnoor, can you tell me what are physical quantities? Any idea about physical quantities?
No.
No?
No.
Okay, Rian.
Sir, there are two physical quantity, vector quantity and scalar quantity.
So what are physical quantities?
Quantities which have magnitude and direction.
nahin. Physical quantities can only have magnitude also, right? But what are physical quantities? Aniket, any idea about it?
Sir, are they like table, chair, and all those things?
Okay, physical. So Shritik, what are physical quantities?
Sir, are they like the quantities which can be measured are known as physical
Very good.
quantities?
So physical quantities are those quantities. Physical quantities can be measured. So whenever they will be measured, they will be having some kind of units also, right? So all those quantities which can be measured are called as physical quantities. For example, 3 liters of water, right? 2 kgs of lemon. Okay. 4 chairs. Okay, Aniket, you got it correct. That table, chairs, these are also physical quantities. But consider this case, 4 chairs, right? Is it having direction? If you place 4 chairs in north, east, west, or south, they remain 4. Yes or no? They are not changing their identity. All of you, yes or no?
Yes, sir.
Yes,
Right?
sir.
Yes, sir.
So these are called scalar quantities. These quantities are called scalar quantities because they only have magnitudes, right? So scalar quantities only have magnitude. Okay. Scalar quantities have only magnitude. Write it like this. Okay. And vectors have both magnitude as well as direction. Okay. Now, examples of vectors are velocity is a vector quantity. I'll write displacement, velocity, acceleration, force. All these are vector quantities. There are many vector quantities, but these are some to be named. Okay. Now, I'll show you how we can say that displacement is a vector quantity. All of you pay attention. Suppose I say that this is u who is moving on this surface, right? So you are moving on this surface. Starting from point A to this point B, which is, say, let's say this distance is 5 meters. Okay. And this is the X, Y, and Z axis. This is east. This is west. This is north. This is south. So can I say that when you have moved from point A, when you have moved from point A to point B, can I say that your displacement is 5 meters along east? Yes or no? All of you, please participate. Yes,
sir.
or no?
Yes, sir.
Your displacement is
5
5
meters.
meters due east.
Yes, sir.
So it has a direction. It has a direction, a magnitude, and this unit is representing that the nature of physical quantity. What is the nature of the physical quantity? I hope all of you understood this. Yes or no? Harnoor, Aniket,
Yes,
Shritik,
sir.
Yes.
Riyan, Advit, Pulsani. Okay. So now we are aware about what are vectors, right? So now how to represent a vector? So now we are writing the symbolic representation. Let's see symbolic representation of a vector. How many of you don't know Hindi? How many of you don't know Hindi? Harnoor, you know Hindi?
Yes, sir.
Okay. Aniket, Hindi aati hai? Shritik,
Yes, sir.
Riyan.
Yes.
Riyan, can you please keep your cameras a little bit tilted so that we can see your face? Yes, very good. And Advit Pulsani, do you know Hindi or not? And please switch on your camera. It's mandatory to attend the session, beta. Chalo. So let's see symbolic representation of vectors. How does it look like? Okay. So we have a vector. It is denoted by an English alphabet with an arrowhead over it. It is denoted by an English alphabet with an arrowhead over it, right? So a vector, or this is also we can write it. The important thing is this arrowhead represents the vector. This is the arrowhead, right? Thick. Now comes the graphical representation of a vector. So this is XY plane. All of you are aware about XY plane. What is an XY plane? You are aware of it or not? Aniket,
Yes, sir.
Shritik, Harnoor, very
Yes,
good.
sir.
Yes.
Okay. So this is I am drawing a vector here. This is the tail of the vector. And this is the head of the vector. Arrow ka head dekha hai na aap logon ne. So this is the arrow head, right? And this is the tail of the vector. ठीक है बच्चों? Now, we measure its angle usually, right? By default, you can say this is vector R, right? If it is not mentioned, please pay attention. I'll give you enough time to write. So don't worry about it, right? If it is not mentioned, then the direction of the vector is measured from the positive x-axis in the anti-clockwise sense. क्या बोला मैंने? The direction of the vector is measured from the positive x-axis in the anti-clockwise sense until and unless it is mentioned. Got it? Shritik, Riyan, Harnoor, Aniket?
Yes, sir.
Yes,
All
sir.
of you? Great. So this is how the direction of vector is mentioned, right? The length of the vector. So what is the length of the vector? This much portion is its length from here to here, right? The length of the vector is shown as its magnitude. The length of the vector is shown as its magnitude. So how do we represent the magnitude of a vector? So magnitude of vector R is denoted as, not given as, is denoted as only by this mod of vector R or only R. Got it? Magnitude of R vector is denoted as mod of vector R. This sign is called as modulus sign. Are you guys aware of this modulus sign? Yes or no?
No, sir.
Yes, sir.
No. If you are not, then this is the modulus sign. And here we are only bothered about the length of the vector. Positive entity. Length can never be negative. Yes or no? Length कभी negative हो सकता है बेटा?
No, sir.
कभी
No,
नहीं हो
sir.
सकता है ना? तो यहाँ पर length is always a positive quantity and that is the magnitude of the vector. Any doubts till this point?
No, sir.
No, sir.
No, sir.
Always remember that conventionally, or I'll write, if it is not mentioned, then the direction of vector is usually measured from the positive x-axis in the anti-clockwise sense. Clear? Any doubts in this? All of you have noted it?
1 minute, sir.
Okay, noted. Once you are done, just type done in the comment window once you have noted it. Bhagyashree ma'am, your students are there?
Sorry, sir.
Your students are there?
Yeah.
And
But
if they have any doubts, just ask them, just ping them for the doubts, okay?
yes, sir. Yes, sir.
Okay. Vectors are the building block of physics.
Okay, sir.
Okay. Vectors and calculus. This is the primary two fundamental basic maths topics which should be learned in very depth, right? Just to understand physics. We will be doing some other topics also like trigonometry. We'll do it a little bit. Trigonometry, linear equations in two variables. But this is where we start. Okay, done all of you? Chalo.
Yes.
So let's move
Yes, sir.
ahead. Now we have learned how to represent a vector, graphical representation, symbolic representation, and what are vectors, right? Now let's discuss about unit vectors first. ठीक है? क्या होता है यूनिट वेक्टर्स देखिए. Vectors which have their magnitude as 1, ठीक है, numeric 1, are called unit vectors. ठीक है. They are used to indicate the direction of right? So my question to all of you is, it can be for any physical quantity, yes or no? It can be for displacement, it can be for velocity, it can be for force, yes or no? Force can be pointing along positive x-axis. Acceleration can be pointing along positive x-axis. Velocity can be pointing along positive x-axis. Yes or no?
Yes,
Harnoor,
sir.
all of you. Yes or
sir.
no?
Yes,
Right.
sir.
So they are used to indicate the direction. It's a generic statement, and the vectors are used like that, right? They are given as the conventional unit vectors are the conventional unit. You know what is the meaning of convention? The conventional unit vectors are I cap, j cap, and k cap. Okay. Along positive x, y, and z axis respectively. Along positive x, y, and z axis respectively. इसको ये जो साइन है ना बेटा, this sign is called as caret. पर इसको पढ़ा जाता है, मतलब कैरेट सब लोग नहीं बोलते, अब कैप बोल देते हैं इसको, कैप, CAP, राइट? तो कन्वेंशनल मतलब, anybody who is aware of what is convention? Harnoor, do you know what is a conventional thing? Convention, what is a convention?
No, sir.
No idea. Aniket? Shritik? Aniket?
No, sir.
Sir,
Okay.
not sure.
Not sure. And we have Rian and Advit.
Sir, conductors and convection. That one.
Sorry.
The conductors and that.
नहीं बेटा, नहीं. Advit, any idea about convention? What is a convention or conventional? Hi Advit. Any idea about conventional thing? No? See, convention is, no worries. Convention is anything which is universally true, right? Matlab, it is applicable for all across the globe. That is what is convention. If I say I cap, everybody will understand that it is a unit vector pointing along positive x-axis. If I say j cap, everybody will understand that it's a unit vector pointing along positive y-axis, and so on. If I say k cap, it's a unit vector pointing along positive z-axis. Now, how many of you are aware about these three-dimensional vectors x, y, and z-axis? All of you are aware about x, y, and z-axis? Harnoor, Aniket? No? If you are not aware, just say no. If you are aware, just say yes, I am. Okay, so except for one,
We
none
are
of you.
aware, sir.
No,
Okay,
sir.
now take your left hand and see the bottom corner of your room. Point it towards the bottom corner of your room. You can see the bottom corner of your room. There are three lines. One line is coming in front of you. Yes or no? From left to right in front of you on the floor. That is the x-axis. Consider it to be the x-axis. One line is going, one edge of the wall, one edge of the room is going towards the roof. Yes or no? Point it upwards. That is y-axis. And the other edge, the last edge, which is coming towards you, right, and going behind you from the corner, that is your z-axis. I hope all of you understood this x, y, and z-axis. Riyan, Aniket, Harnoor, Shritik,
Yes, sir.
Sanvi, and Bhagyashri.
Yes, sir.
Advit.
Yes, sir.
Okay. So this was, yes, Sanvi. You want to ask anything, something? Please switch on your camera. Sanvi, please switch on your camera. Yeah. You understood or not? You joined late. कुछ आया समझ में बेटा? चलो ठीक है, जो भी आया ठीक है, तुम मेरे को पूछते जाना, ठीक है? आई कैप, जे कैप, के कैप यूनिट वेक्टर्स होते हैं. यूनिट वेक्टर का मैग्नीट्यूड 1 होता है, उनकी लेंथ 1 यूनिट होती है, ठीक है? अभी यही है. और वेक्टर्स को हम ऐसे डिनोट करते हैं, ए वेक्टर, बी वेक्टर, ये जो ऊपर होता है एरो हेड लगाते हैं, ठीक है। अभी यहां से चलते हैं आगे, आई विल सेंड यू द रिकॉर्डिंग, डोंट वरी, ओके। सो नाउ कम्स, this was a unit vector, right? So how do we use this unit vector to show the direction? Just take this case. This is x axis and this is y axis, ठीक। यहां पर ये origin है, okay, and you are walking say 3 units in the forward direction, right? This is point A and this length is 3 meters. So you reached this point, okay. So the displacement is, or I'll write it as vector OA. O is the tail of the vector, O is the tail of the vector and A is the head of the vector, right? So OA vector is equal to, it is 3 units I cap. It is pointing along which direction? It's 3 meters, sorry,
Positive x-axis.
3 meters I cap. This is the displacement of, this is the displacement of this man. I hope all of you understood this. Yes or no?
Yes.
Yes, sir.
Any doubts? Sometimes, yeah, most of the
Okay.
times we denote it by one English alphabet, say R vector, and we can write it as R vector also. The magnitude of this vector R is this unit 3. This is representing the physical quantity it is, right?
Yes, sir.
And this is representing the direction. So if I say, चलो यहां से ही चलते हैं, ठीक है। Please pay attention. If you take a left turn, if you take a left turn and move say 4 units in this direction, say 4 meters, right? And this point is B. What is vector AB then? Any one of you or all of you, tell me what is vector AB then? How will you write vector AB? All of you are aware that 4 meters is its
Yeah.
magnitude and direction,
Magnitude.
magnitude and physical quantity, right?
Yes,
What is
sir.
the direction associated with y-axis?
J cap.
J cap. Very
J
good.
cap.
It's J cap, right? So this is how we write vector AB. All of you understood this or not? Any
Yes, sir.
problem, any challenge in this?
No, sir.
No? Good. So these are the vectors. Now, what are the unit vectors along negative x, y, and z axis? So suppose this is vector A. Please pay attention. Suppose this is vector A and you want to write minus A vector. So what you need to do is just rotate this vector A about its tail by 180 degrees. Right? So this is vector minus A. You are rotating it about its tail. This is the tail. Fix the tail and rotate it by 180 degrees. So this is minus vector A. All of you clear about this negative vector?
Yes, sir.
Harnoor, Aniket, Riyan,
Yes,
Shritik,
sir.
Advait, Sanvi, and Bhagyashri.
Yes, sir.
That's great. Till this point, acha, okay, note it down and then we will move ahead. If you have any doubts, you can ask.
So, sir, conventional unit vectors associated with y-axis is j cap and x-axis is I cap.
Yes. And z axis is k cap.
Okay, sir.
And what about minus y cap, minus y axis. What about negative y axis? What will be the unit vector along that direction?
Sir, negative j cap.
Yes, excellent. Very good. Once you are done, just let me know you are done, okay? Shritik, you are aware of these things, right?
Yes, sir.
Good. All of you done?
Yes, sir.
Rian? You're not audible, Rian. Advait done?
Yes.
सानवी जी लिख लिया आपने? सानवी done? I will post the recording in this group only, okay? Don't worry. The demo group, the demo class group hai na jo? I'll post it in that group. So what if something is left, you can copy it and learn from there. Chalo. So now let's learn what are position vectors, right? Position vectors. So vectors which are used to indicate the position of a particle with respect to a reference point are called position vectors. ठीक है? Vectors which are used to indicate the position of a particle with respect to a reference point are called position vectors. Okay. ये है. ठीक है? Now, suppose you take any object in your room. Identify one object in your room. Identified, which is distant from you in the room, right? And treat your shoulder as the tail of the vector and your fingers as the right hand palm fingers as the head of the vector. Now imagine it is stretching to that object. So this is the position vector of that object. Suppose I'm there is a chair, there is a glass in front of me and I'm pointing my hand towards it. So that this is the position vector of this object. Understood? The tail is at the reference point with respect to you. This is the position vector with respect to you. The tail is at the reference point and the head is pointing towards the object. All of you understood this?
Yes, sir.
Good. So now this is x-axis, y-axis. This is x-axis, and on this xy plane, we have a tail here and a head, an object, another object at this point, right? So this is some object A, and this is the reference or the origin O. If I want to write position vector, how to draw position vector of a particle? If I want to draw position vector of this particle with respect to O, मुझे इस ऑब्जेक्ट का पोजीशन वेक्टर ड्रॉ करना है O के रिस्पेक्ट में. ठीक है? कैसे कैसे ड्रॉ करूंगा? तो आई विल जॉइन इट बाय ए स्ट्रेट लाइन, और एरो हेड कहां रहेगा? पॉइंटिंग टुवर्ड्स द ऑब्जेक्ट, और टेल ऑफ द वेक्टर कहां रहेगा बेटा? रेफरेंस पे रहेगा, राइट? सो इट इज एट द रेफरेंस. सो दिस वेक्टर इज नाउ रिटन एज position vector of, I am denoting it by in English alphabet, position vector of A with respect to O. Position vector of A with respect to O. Right? How will I read it? It is read as position vector of A with respect to O. Clear hai sabko? Any doubts? Shritik, Harnoor, Aniket, Bhagyashri, Sanvi, Advit, Riyan. Okay. Okay. Now there is another point here, and one of you will have to answer it. This is another point here. Say another particle B. Harnoor, tell me, how will you draw the vector here? The position vector of B with respect to O.
We'll
Kaise draw?
draw a straight line from O to point P.
Very good. And the vector will be pointing towards?
And the vector will be pointing, what? I'm sorry, what?
What will be the direction of vector? Where will the vector point towards?
Will point towards P.
Very good. And the tail of the vector will be at?
O, the
Oh,
reference point.
shabash. And how will we write it, beta?
Like a vector R with
B with respect
B
to
with
O.
respect to O, yeah.
And you will read it as?
Position vector
Huh?
B with respect to O.
Shabash. Very good. Position vector of B with respect to O. All of you understood this? Yes or no? Now,
Yes, sir.
I want all of you to draw in your notebook. First, you copy this and then you draw what is R, B, A. First, you draw and then I will ask one of you to explain it to me. Okay? Do it. Copy this in your notebook and then draw this vector RBA. सानवी, आपको समझ आया बेटा? चलो शाबाश, वेरी गुड. Once you are done, just type done in the comment window, okay? Advit, you understood? Chalo. So who is going to tell me how to draw RBA? Shritik?
Sir.
Bolo. How to draw it?
Sir, we have to take the reference point as A and
Okay.
draw a straight line from A to B, sir. So so we name it as R bar. We say it as position vector of B with respect to A.
Very good. Shabash. So this is how we write the vectors, right? These are called position vectors. So we know now what have we learned? We know what are unit vectors, and second we know now position vectors, right? And you have copied it also. No. Let's try to learn how to write a unit vector along the direction of a given vector. Please pay attention. So this is our agenda abhi. ठीक है, discussion का. So what we will do here is, okay, suppose I have a vector like this. R vector is 3 I cap. It can be any physical quantity, right? Now what is the unit vector associated with the direction of R vector? Which unit vector is associated with direction of R vector? Aniket? Which unit vector is associated with direction of R vector? कौन सा यूनिट वेक्टर R को दिखा रहा है बेटा? R का डायरेक्शन कौन सा यूनिट वेक्टर बता रहा है?
Sir,
बोलो बोलो. अच्छा, यूनिट वेक्टर क्या करता था?
sir, unit vector used to represent the x-axis, y-axis, and all
डायरेक्शन बताता था ना यूनिट वेक्टर.
हाँ sir.
है कि नहीं? तो यहाँ पर कौन सा यूनिट वेक्टर R का डायरेक्शन बता रहा है?
Sir, east.
नहीं, I cap. Harnoor, I cap. Right? And it was x-axis. Advait, I cap. Unit vector which is representing the direction of vector R is I cap. All of you understood this or not?
Yes sir.
Suppose I write, say there is another vector S vector. And this is given as 4j cap. So which unit vector is representing the direction of vector S? Harnoor?
J cap.
J cap. Very good. Advait, suppose I have another vector T vector, say. Now I have this vector as 5k cap. Now which unit vector is representing T vector's direction? K cap. Very good. All of you understood this? Yes or no?
Yes, sir.
Now, I'm just.
Yes, sir.
Magnitude of vector R is how much? What is the magnitude of vector R? Just a second, I'll ask someone else. Riyan, what is magnitude of vector R?
Three.
Okay, good Advait. It's 3. Very good. It's 3. Right? Now, if I divide, pay attention. If I divide vector R from R, if I divide the vector by its own magnitude, see, I get 3 I cap upon 3, and this 3 and 3 cancels out. Yes or no? What I am left with is a unit vector. Yes or no? And this is the unit vector along the direction of vector R. This is unit vector along the direction of R vector, right? I hope all of you understood this. Yes or no?
Yes sir.
So we can write this as R cap. All the unit vectors can be denoted by this cap. So when we are writing R cap, that means the magnitude of vector R cap is 1. I hope all of you understood this. Yes or no?
Yes, sir.
सानवी को समझ आ रहा है? सानवी understood बेटा? सानवी जी आपकी आवाज नहीं आ रही है. Okay, thumbs up. Very good. Thank you so much. Okay. So whenever we want to write a unit vector along the direction of a given vector, we divide the vector by its own magnitude, right? Whenever, or to find a unit vector along the direction of a given vector, we divide the vector by its own magnitude. I hope all of you understood this concept. Yes or no?
Yes, sir.
Good. Copy it.
Yes, sir.
So shall we move ahead? Done with it? Type done in the comment window if you have done writing with this part. Okay. So now let's discuss addition of vectors. Okay. Addition of vectors. Now, before I start to tell you how the vectors can be added, this is the statement which you need to remember. A vector never changes if it is moved parallel to itself. If it is moved parallel to itself. Right. So this is what you guys need to remember. Now pay attention. We can add vectors representing similar physical quantities. I repeat, we can add vectors representing similar physical quantities. हम similar physical quantities वाले vectors को ही add कर सकते हैं. For example, 3 meters plus 3 meter I cap plus 2 meter I cap. Displacement. तो ये मीटर है इसलिए हम इसको ऐड कर सकते हैं. 3 मीटर पर सेकेंड प्लस 5 मीटर पर सेकेंड इसको ऐड कर सकते हैं. ठीक है. एक और एग्जांपल देता हूं, थोड़ा सा क्रूड एग्जांपल है बट आपको समझ में आएगा, आपको याद रहेगा. तुम 3 बंदर प्लस 5 हाथी, 3 बंदर प्लस 5 हाथी, 8 हाथी बोलते हो क्या? नहीं. 8 बंदर बोल सकते हो? नहीं ना. क्यों नहीं बोल सकते हो? क्योंकि ये दोनों अलग अलग फिजिकल क्वांटिटीज हैं. राइट. So when scalars, different physical quantities representing scalars can't be added, so vectors also can't be added together. Understood? And they follow a different set of addition rules. अभी तक हम लोग न्यूमेरिक ऐड करते थे तो हम सिंपल काउंट करके बोलते थे 2 + 3 5 होता है. यहां पे ऐसा नहीं होगा. ठीक है. तो we need to learn that. Right. So before we move ahead, let's try to learn how to add two vectors. So we have this vector A, okay, and this is another vector B. Right. Now, fix any one of these vectors first. Take any one of these vectors as a reference vector. किसी भी एक वेक्टर को आप रेफरेंस वेक्टर ले लो. ठीक है. अद्वित, इधर ध्यान देना है. किसी भी एक वेक्टर को रेफरेंस वेक्टर ले लो. ठीक है. तो किसको लेना चाहते हो आप? ए को कि बी को? Which one of the vectors you want to take as a reference vector? Reference मतलब we will make it, we will fix it.
Sir, A.
चलो A. Done. तो A को fix कर दिया. ठीक है. Now what we will do is we will move B in such a way. We will move B parallel to itself. We will move B parallel to itself such that the tail of B coincides with the head of A. The tail of B coincides with the head of A. And this is vector B. Has it changed? Can you see neither the direction nor the length? Nothing has changed for this vector. Yes or no?
Yes, sir.
Yes, sir.
So we can say that if these two vectors are placed like this, that tail of one of the vectors is lying on the head of another vector, then we can say that the remaining tail and head, this was the tail which was remaining, and this is the head which is remaining. Place a vector in between them, and this is a vector C which is representing the sum of these two vectors, vector A plus vector B. Okay. This is vector A plus vector B. Clear? And since it forms a triangle, it completes the triangle, right? This is called as triangle law of addition of vectors. Triangle law of addition of vectors. This is what we call it. Understood all of you? क्यों बोलते हैं ट्रायंगल लॉ बेटा? इसलिए बोलते हैं क्योंकि ये ट्रायंगल फॉर्म करता है, सिंपल है. और कैसे ऐड करते हैं? We take one of the vectors as a reference vector and parallel to the and move the other vector parallel to itself such that the tail of vector coincides with the head of the previous vector or the reference vector. The remaining head and tail will form a new vector that is called as vector C, and it is the summation of these two vectors. Now my next question to all of you is or not here, let's write it here. Is A plus B equal to B plus A? Now this is a question, right? So what we will do is, now let's change the game. Here we have vector B, right? We will now keep vector B as a reference vector and move vector A parallel to itself such that the tail of vector A coincides with head of vector B. A का tail, A की पूंछ B के सर पे आ गई, देखो. ठीक है? और यहाँ पे क्या था? B की पूंछ A के सर पे थी. Right? So this is vector A. And now join this tail and head. Can I say that the vector, can you see that the vector looks identical, C vector and C vector from here?
Yes, sir.
Yes, sir.
So we can easily say that vector C is equal to vector B plus vector A. I hope this is clear to all of you. So the answer to this is yes. Okay, copy it. Once you are done, just type done in the comment window. अनिकेत को समझ आ रहा है कि नहीं आ रहा है? ओके,
सर समझ आ रहा है.
वेरी गुड. सो नाउ लेट्स सी हाउ टू. चले आगे.
हाँ सर.
Riyan, understood? Noted? Sanvi, noted and understood? Sure. So now, how to resolve a vector in its components? Now, all of you tell me, do you have a pen which can be opened? Different components of that pen can be opened. You can open the refill or not. You can take it out. See, I have a pen, right? All of you do this. Those of you who have this pen, kind of pen which can be which whose components can be taken out. So I have dismantled the pen, right? So these are the components or parts of this pen. Yes or no? Now, can
Yes,
I put
sir.
it together? Of course, yes. If I put it together, can I get the pen? Of course, yes, right? When I
Yes.
put it together, I get the same pen back. So similarly, a vector can be resolved into its components, the way I have resolved this pen into its components. And when I add those components together, I'll get the same vector back. Okay, I'll get back the same vector. So now, how to resolve a vector can into its components? So here is it. It is so a vector can be resolved. A vector can be. We are talking about planar vectors, right? So a planar vector. You know what is a planar vector? A vector which lies on the plane, right? A planar vector can be resolved along any two mutually perpendicular and coplanar lines. Coplanar with the vector, right? These lines are coplanar with the vector. A planar vector can be resolved along any two mutually perpendicular and coplanar lines. Right? Now, all of you just pay attention here. This is the XY plane, right? This is the XY plane. You type your answers in the comment window. How many pair of such coplanar lines can be drawn on this plane which are mutually perpendicular to each other? I repeat my question. How many such mutually perpendicular coplanar lines can be drawn on this plane? Type your answer. Anybody? I didn't get any answers. How many? Okay, very good, Shritik. Very good, Harnoor. Aniket, I'm waiting for your answer. Aniket, Advait, Riyan, Sanvi. मैं फिर से पूछता हूं, क्वेश्चन सुनो बेटा. एक्स वाई प्लेन, एक्स वाई एक्सिस एक पेयर ऑफ लाइन है, ठीक है, इस प्लेन में ऐसे कितने आप पेयर ऑफ लाइंस ड्रॉ कर सकते हो जो म्यूचुअली परपेंडिकुलर है और इसी प्लेन में लाई करेंगे? ओके, अनकाउंटेबल, अनकाउंटेबल, इनफाइनाइट. सानवी समझ आया बेटा क्वेश्चन? इसमें इनफाइनाइट लाइंस हैं. कैसे इनफाइनाइट है देखो. I will draw a few pairs for you. See, these are perpendicular to each other. These are perpendicular to each other. These are perpendicular to each other, right? So ऐसे कितने pair of lines हो सकते हैं? Infinite. Clear? Now, I have a vector along this direction. See, this is the vector now. And the magnitude of vector is r. And the angle which it makes with the x-axis measured in anti-clockwise sense is theta. Okay. Please pay attention. Right. This is the vector's length. The length of the vector is r, magnitude of r, right? Now, how to find, please pay attention. हाँ, सुनो ध्यान से बेटा, ये बहुत इंपॉर्टेंट है, ये समझ में आना चाहिए, बहुत जगह यूज होता है फिजिक्स में, ये बहुत सारी जगहों पे ये, और काफी आसान है, समझ में आएगा आपको. What you do is, I want to find the projection of this vector, or I want to resolve the vector into its component along x-axis. कहाँ मैं resolve करना चाहता हूं इसको? x-axis में. मतलब मैं इस वेक्टर का प्रोजेक्शन, प्रोजेक्शन मतलब समझते हो, शैडो, ठीक है, मैं इस वेक्टर का शैडो कहां देखना चाहता हूं? एक्स एक्सिस पे. कंपोनेंट ऑफ वेक्टर कहां देखना चाहता हूं, एक्स एक्सिस पे। ये सब एक ही चीज है, प्रोजेक्शन, शैडो, रिजॉल्व करना, ऑल दीज आर सेम थिंग्स। ठीक है। नाउ व्हाट आई डू हियर इज I will put light on this vector. I am just putting light on this vector, right? And I am assuming it to be opaque. The light is coming directly from the parallel to y axis, right? Now, this is the tail of the vector, this is the tail of the vector, and this is the head of the vector, right? Now, draw perpendicular, please pay attention, draw a perpendicular from the tail of the vector on the x-axis. Drop a perpendicular from the tail of the vector on the x-axis and drop a perpendicular from the head of the vector on the x-axis. All of you understood this? Yes or no?
Yes, sir.
Anybody is having any doubt in this? Aniket, Shritik,
No, sir.
Advait, Riyan, Sanvi,
No, sir.
right? So the shadow of tail will be a tail. The shadow of head will be a head, right? The shadow of tail is a tail and the shadow of head is a head. So this is the vector which is here. It becomes a vector only, and this is R X vector. All of you understood this? Yes or no?
Yes.
Right?
Yes.
Now, what about the y component? So this is read as x component जिस भी एक्सिस के along है बेटा, ठीक है? तो x component of r vector, ऐसे पढ़ेंगे इसको, ठीक है? Now what about the y component? So again we will do the same thing. We will drop a perpendicular from the tail of vector on y axis, from the head of vector on y axis, and we have this thing here. This is vector r y. This is the tail of vector r y, and this is head of vector r y, right? And this is read as what? This is y component of vector r along y axis, or sorry, y component लिख तो दिया मैंने, ठीक तो है, or component of vector r along y axis. All of you understood this? How to resolve a vector? Say
Sir.
yes or no.
Yes, sir.
Yes, sir.
Yes.
ठीक है? Now, as I said that if we add the components, we will get the same vector. So let's try to add the vectors, add the components of it. How will we add it? अभी सीखा था ना add करना हमने. What we will do is we will bring this vector parallel to itself and such that this is vector Rx. Okay. And now I am bringing in this vector Ry parallel to itself such that the tail of the vector coincides with the head of vector Rx. This is vector Ry. Clear? All of you understood or not?
Yes, sir.
So this is vector Ry, this is vector Rx. That's it. So can I say that vector Rx is added with the vector Ry to give us vector R? Can I say like this? Yes or no?
Yes, sir.
Rx is
Yes,
adding
sir.
up with Ry vector to give us vector R. Clear hai beta? Following the triangle law of addition of vectors?
Yes, sir.
Good. So please copy it, and this is how we resolve a vector into its components. Shall we move ahead? Good. Done, all of you?
Done, sir.
Okay.
Done, sir.
Chalo. So this was all for today's session. Okay.